So this is OCR's paper 5, the non-calculator paper. It's from June 2022, higher tier. And if we have a look at the grade boundaries, you need 13 marks for a 4, 24 for a 5, 35 for a 6, right up to 74 marks for a grade 9. So in question 1, we've got a straightforward pie chart question, and we're just asked why this pie chart is not suitable. So there's at least two reasons. The first being the fact that it's three-dimensional makes it hard to see the actual proportions of each part. It's all grey, so it's hard to see which colour is which. Part B of this question, we've got a time series graph showing data about computer tablet users, and it says what's the percentage increase from 2014 to 2018. Well, in 2014, we had 0.8 billion. In 2018, we had 1.4 billion. I'm not going to convert to billions, I'm just going to use these figures. If we want percentage increase, let's firstly look at the increase, and that's just going to come from 1.4, take away 0.8, that would be 0.6. The percentage increase is going to be the increase, that 0.6, out of the original. So it started at 0.8. So we need to do 0.6 divided by 0.8 and then times 100 will change that into a percentage. There's also another way to change into a percentage. I'm just going to manipulate this fraction. So if I divide top and bottom by 4, I get 0.15 over 0.2. Why would I do that? Well, I can now multiply top and bottom by 5, and I get something over 1. 5 15s is 75. Why would I do that? Well, if I now multiply top and bottom by 100, I get out of 100, and that's my percentage. So timesing by 100, timesing by 100, 75 out of 100 is a 75% increase. Question 2, we've got some bearings work to do, so apologies, this is not going to be great on the device I'm working on. It says the bearing of a tower from castle J is 0.72. So here's J. What I'm going to do is measure around 72 degrees, which will be about there, just using a protractor. And then I'm going to go up like that, just a straight line. Okay, so that there is 72 degrees. It says the bearing of the same tower from castle K is 116 degrees. So there's K. Again, grab a protractor. You're going to measure around beyond 90 degrees. It'll be about there to 116. And I'm just going to draw that. Here is your tower, the tower that it's talking about. It says find the distance from castle J to the tower. So what we need to do is grab a ruler and now measure this distance. And let's pretend that comes out at 3 centimeters. It's not going to, but let's pretend it is. We now just need to convert that distance there to kilometers. So whatever you measure here with the ruler, mine is 3. We're going to multiply by 2 because every centimetre is 2 kilometres, and I get 6 kilometres. That's not the correct answer. I've checked the mark scheme. The mark scheme is anywhere between 11 and 14, something around that. Question 3, we've got some standard form work to do. It's talking about dinosaurs appearing on the earth and becoming extinct. Why are we using standard form? Simple reason, you're dealing with big numbers. Extremely long time ago, we're going to use standard form rather than write out all the zeros involved in that number. Part B says, how long were dinosaurs on the earth for? So what we need is the difference from when they appeared and when they became extinct. And I'm going to use the biggest number first. They appeared the longest time ago, 2.4 times 10 to the 8 years. And I'm going to subtract when they went extinct, which is 7 times 10 to the 7 years ago. Several ways to do this. I'm just going to go old school. I'm going to write this as a normal number. So we've got a 2 and a 4. And then I'm going to have 7 zeros. 1, 2, 3, 4, 5, 6, 7. Not 8 zeros. The first times 10 changes this to 24. Same with this. I'm now going to have 7 with 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Let's work this through. Note take note is no. And you're going to get the same all the way along here. 4 takes 7 we can't do. So we're going to borrow and do 14 takes 7. And then 1 is just 1. There is your answer, but it does say give your answer in standard form. So I've got a 1 and a 7. I'm going to write 1.7, remembering this first number has to be between 1 and 10. And in standard form, we've got 1.7 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 1.7 times 10 to the 8. Question 4, a bit of powers work to do. We're looking to hit 784 by multiplying something by 49. 7 squared is 49. Well, it's not 2 to the 1, because 2 to the 1 times 49 is 49. 2 squared is 4. 4 49s won't come near this. 2 cubed, 2, 4, 8. 8 49s, we'll think about 8 50s. That would only be about 400. I think it has to be 2 to the power of 4. 2 to the power of 4 is 16. And if we think about 16 times 49, well, let's just look at 16 times 50. A half of 16 is 8. So 16 times 50 would be 800, which is very close to 784. So I'm pretty confident that that is a 4 there. Part B says use this answer to find the square root of 784. So we're looking for something squared to be 784, so we can work out the square root of 784. Well, we know that 2 to the power of 4 times 7 squared is 784. If I just rewrite 2 to the power of 4 as 2 squared times 7 squared, and what that is 4 squared times 7 squared, and 4 squared times 7 squared is the same as 4 times 7 all squared, and that's 28 squared. 28 squared will be 784. Question 5 is a horribly worded question, quite hard to keep track of this. So what we've got is just a conversion. 3 teaspoons is the same as 1 tablespoon. And then we've got a recipe that uses 3/4 of a teaspoon and 1 tablespoon. And it's the 1 tablespoon of baking powder that I'm going to focus on. So if we just look at the baking powder, that's 1 tablespoon. And I'm going to use that conversion to say, well, that's the same as 3 teaspoons. So I've converted here the baking powder into teaspoons. If we now go back to the cake recipe, look at salt to baking powder. We've got 3/4 of a teaspoon of salt and 3 teaspoons of baking powder. So I've got my ratio by doing that initial conversion there. What we're trying to do is write this in the form 1 to something, 1 to n. So we've just got to convert this ratio so we can get a 1 where this salt is. So what we can do first is maybe times by 4. And what that will do is get rid of this divide by 4. And you're left with 3 to 12. And then how do we get a 1 there? We're going to divide by 3. So divide by 3. And your n is 12 divided by 3, which is 4. Question 6, we've got some information about scoring points, and someone plays this game 100 times, and what we've got is the relative frequencies of their scores. So the first thing we need to know is all these relative frequencies always add up to 1. So I'm just going to see what I've got to start with. I've got 0.08 added to 0.42 added to 0.38, and what that comes to, that's 18. 3, 4, that's 8, and we've got 0.88. So this box here is going to be 1, take away 0.88, and that is 0.12. My friend Morgan says I scored more than 160 points in the 100 turns. So what we've got in the table is basically how many times out of 100 they got 1 point, how many times out of 100 they got 2 points. If I take this 0.42 and multiply it by 100, what we get is simply 42. So they got 1 point 42 times. So I'm going to multiply that by 1. If we look at how many times they got 2 points, well, I'll just do 0.38 times 100. And that's going to tell me how many times they got 2 points. So that's how many times they got 2 points. For total points, I'll multiply by 2. And 2 times 38 is 76. They got 3 points a certain amount of times. And how many times was that? Well, 0.12 multiplied by the 100 times that they played. 12 times they hit 3 points. So 12 lots of 3 is 36. And if I total these, I'll get their total amounts of points. 42 add 76 is 118. This would be 148. Add on the 6 is 154 points. It says, is Morgan correct? Make sure you say, no, Morgan is not correct. Question 7, we've got some acceleration, a time, and an initial velocity. And then we're looking at this Suvat equation, which is linking all of these things together. You need to know about this equation down here. U is your initial velocity. That's the one that's not obvious. The rest should be a bit more obvious. T is time. And A is acceleration. The thing we're actually trying to work out is S, which is the distance travelled. So we have U, T, and A. What we're trying to work out is S. Now it does say round these figures to one significant figure. So I'm going to do this now. My acceleration of 4.06 becomes 4. My time of 10.1 seconds becomes 10. And my initial velocity of 2.93 becomes 3. So I've rounded each figure to one significant figure. Now I'm going to do the substitution into this equation. So S is U times T, which is 3 times 10, plus a half AT squared, which is a half, times 4 times 10 squared. And if I just work this out, I end up with 30 in this bracket. Make sure you square this first, so we're going to get 100 from that. Times 4 is 400, then halved is 200. So you end up with 30 plus 200, which is 230 meters. Harper said 430. I've just got full marks by showing that they're way wrong. Part B is a rearranging to make T the subject. So quite a difficult one. I'll just rewrite this out. We've got S equals a half AT squared. I'm going to leave the T alone and rearrange everything else. So this halving is dividing by 2. And we can undo that by multiplying by 2. And we end up with 2S equals, I've got rid of the halving now, AT squared. Remember, we're leaving the T alone, so we'll divide by A. And we end up with 2S over A equals T squared. Final step to get T on its own is to square root both sides. My final rearrangement will be T equals the square root of 2S over A. Question 8, we've got quite a tricky probability question. We've got red, blue and yellow marbles in a bag. Now, what we don't know is how many marbles in this bag. So I'm going to skip over this first bit because that's talking about the red marbles. What we'll just look at first is the yellow marbles. So we know that the probability of yellow is 9 out of something. We do not know how many marbles in the bag. We know blue marbles, the probability is 3 times as much as the yellow marbles. So blue marbles, well, 3 9s are 27, and that's also out of the same something, the same total. We do know that red probability is 2/5, but that's not saying there are 5 marbles in the bag, because that's the simplified probability. They could be 4 out of 10 or 8 out of 20. So we don't know this total. What we do know is if we add those 3 fractions together, then that's going to give us everything. That's the whole one. So we can kind of start to work this through at this point in time. So what I'm going to do is just add this fraction together on the left. 9 somethings add 27 somethings is 36 somethings. We've already got common denominators there, if you like. Added to 2/5 comes to the whole one. What I'm going to do now is just start to solve this. If I know this add 2/5 come to 1, then this here, 36 somethings, will just be 1 take away 2/5. And 1 take away 2/5 is 3/5. So all I've got to do now is convert this fraction of 3/5 into 36 somethings. So I'll just rewrite it. 3/5 equals 36 somethings. Well, if I multiply that by 12, I get 36. So I'm going to multiply that by 12, and 5 times 12 is 60. Question 9, we've got a diagram of a sandpit, and we've got something that's already been drawn. This zone here is all the points 80 centimetres from this corner. So if we actually go down to the question, it's saying you get 1 point if the ball lands within 80 centimetres of the corner. So if you land this ball anywhere in that zone, you get 1 point. We need to work on these next constructions. It says you also get 1 point if the ball is closer to AB than AD. So closer to this line than to this line. And what that's telling you to do is cut this angle in half. So we're going to need a compass to do that. I'm going to use this arc that's already drawn. You're going to put your compass point here and draw an arc around it. You're then going to move your compass pointer here without changing the compass and draw an arc around that. And if we connect that crossover zone there, we've cut the angle in half. I'm sorry, that's a bit rough doing it on a device. And it says you get 1 point if the ball is closer to AB than AD. So all of this zone will be 1 point. If you're in this part here, you now get 2 points because you're closer to AB than AD, but also within this first arc. So I'll just jot that in as well. You also get 1 point if the ball is closer to A than B. So there's A, there's B. Closer to A than B means cut that line in half. And again, use a compass for that. So compass point on A and draw an arc. Compass point on B without changing it and draw an arc. And if you connect those two crosses, you'll have cut the line in half. So mine's very rough and I do apologise, but hopefully you understand the idea. And it says closer to A than B also gets a point. So on this side of the line gets a point. I'm not interested in that zone because actually the question says 2 points. So where do we get 2 points? Well, this part here now has just moved to 3 points because that covers everything. Okay, closer to the point A, closer to this bottom line, and within the section. So that bit there is 3 points. That's no good. This bit up here is actually 2 points because I'm within that first arc and I'm on the left-hand side of that line. I'm closer to A than B. So that's 2 points. There's somewhere else which is 2 points, which is down here. Okay, I'm closer to AB and I'm on the left of the green line. So I'll shade it in so hopefully you can see it. That there is also 2 points, the same as that one. You're looking for all the zones where 2 of these 3 things are met, and it's in those 2 green parts there. Question 10, we've got an enlargement to do, and the scale factor is 1.5, and we need the centre of -8, so across to -8 and up to 0, so that's where we're enlarging from. What we're going to do is draw this shape 1.5 times bigger, but the distance from this point to each corner also needs to be 1.5 times bigger. So I'm going to do it point by point. If we just focus on this point here, how do we get from this to this? Well, I'm just going to count up and across. So we're going to go 1, 2, 3, 4 up, and 1, 2, 3, 4, 5, 6 across. I'm going to do that distance 1.5 times. So I've done it once already. I'll now do it another half. So 4 up becomes 2 up, and 6 across becomes 3 across. I have now done that distance 1.5 times. I'll do the same with this point. That is simply 1, 2, 3, 4, 6 across. I've done that distance 1 times. Now let's do it another half. So 6 across becomes 1, 2, 3 across. And what I can do at this point is maybe just start to draw the triangle. So those 2 points are going to connect. And now look at this top measurement, which is 2 across. So let's draw that in, 2 across. Remember the scale factor is 1.5. So there's the 1 and there's the half. And at this point now I can just draw my triangle. There's the enlargement. And part B of this question, we've got A to B in terms of something's happened. And we know that there's been a reflection in the x-axis. What we don't know is the initial transformation that happened to A. So what I'm going to do is say, well, if there was a reflection in the x-axis to get to B, let's undo that. Let's undo that reflection. What I'm going to do is just reflect the triangle in the x-axis. And what we'll get is that. So that is a reflection in the x-axis. What I need to know is how to get from this to this. Well, certainly this has been a rotation, so we'd write that down. That has spun around. You've got a rotation. It is half a turn. That triangle has turned half a full circle, so it's 180 degrees. I don't need a direction because a half a turn is just half a turn. Where's the centre of rotation? What has this spun around? I think that seems to be my centre of rotation. If you got some tracing paper and traced this triangle and then put your pencil on this point and spun half a circle, you'd land perfectly there. So we need to say the centre is 1, 3. And there's your transformation. Question 11, we've got some algebraic proportion to do, and it says y is inversely proportional to x squared. Inverse proportion starts like this. Y x equals a constant. Some people would say y equals a constant over x. Same thing, I prefer this version. Be careful, this is actually proportional to x squared, so we need the squared there. I'm going to continue just working on this one, but you could use this version if you prefer. It says y is 9, x is 2. So let's just substitute those in. 9 multiplied by x is 2. 2 squared is my constant. 2 squared is 4, and 9 times 4 is 36. So I know that k, my constant of proportionality, is 36. Let's rewrite that initial formula with this k in place. Y multiplied by x squared equals 36. And it says find the value of y when x equals 10. So x is now 10. Y times 10 squared equals 36. That becomes y times 100 is 36. So y is going to be 36 divided by 100. Well, 36 divided by 10 is 3.6. Divided by 100 would be 0.36. Question 12, we've got a speed time graph. It's talking about an athlete, and it says, what's the athlete's acceleration between 400 seconds, so this point, and 1,000 seconds, this point? Well, they're always at 4 meters per second, so their acceleration is 0. They're not changing speed, and acceleration is how fast they're changing speed. So the acceleration there is 0. We're told in part B to work out the average speed during the entire graph. Now, if we're going to work out average speed, we're going to need distances. We've got the time covered in this graph, 1200 seconds, but we need distances. And distance from a speed time graph just comes from the area underneath the graph. So what we've got is 3 areas to work out. That first triangle is going to be base times height divided by 2. So we've got a base of 400, a height of 4, and divide that by 2 because it's a triangle. 400 times 4 is 1600, divide by 2. That's 800 meters in that first triangle. This rectangle is a bit easier. That is from 400 to 1,600 across and still 4 high. 4 sixes are 24, so you've got 2,400 meters there. And then we've got another triangle to work out, so I'll just sketch that here. And again, base times height divided by 2, so the base is 200. We're multiplying by 4 again because that's the height, and dividing by 2. This comes to 400. This comes to 800 divided by 2, which is 400 meters. Remember, we're trying to work out the speed, which is distance divided by time. Total distance, 800 add 2,400 is 3,200. Add this on, you get 3,600 meters, and we're dividing it by time, which is 1,200 seconds. We can quickly say 1, 2, 3, 4, they're gone, just dividing top and bottom by 100, and you get 36 divided by 12, which is 3 meters per second. Okay, question 13, we've got a quadratic, and someone's drawn the graph of that quadratic, and it says calculate y when x equals 1. All I'm going to do is put 1 into this equation. X squared plus 6x minus 2, so x becomes 1, y becomes 1 squared, add 6 times 1, 6x's, and then take 2. This is 1, add 6, that's 7, take 2, which is 5. Part 2 says, without solving the equation, why must Q, this part, be between 0 and 1? Well, if you put x equals 0 into this equation, you get 0 squared plus 6 noughts, take 2, what you'll get is a negative answer. When you put x equals 1 into this equation, what we've just done, you get a positive answer. This actual point Q is where you want 0 as an answer. So 0 lies between negative and positive, so the solution to the actual equation must be between 0 and 1. Part 3 says, why is iteration not the best way of finding a solution to this equation up here? And I'll just write that in now. It's too slow, it takes too much work. The quadratic formula is much better and will solve this equation quite quickly, quite easily. And then finally, we're told what the exact solution for Q is, and this is what we get here. And then we need to almost simplify this answer. So all I can see is I've got a surd to deal with, and that will actually simplify. Root 44 is root 4 times root 11. 4 11s are 44. And root 4 is actually 2. So what you end up with, root 44 is 2 root 11. What I'm going to do is rewrite this solution using that. So I get minus 6 plus, not root 44 anymore, 2 root 11, all divided by 2. And now we've got things on top and bottom that will actually both divide by 2. Minus 6 divided by 2 is minus 3. And 2 divided by 2 is 1. So this just becomes minus 3 plus root 11. Question 14, we've got quite a tricky Venn diagram to do. What we're given is students who like pop, which is all of these people, and students who like rap, which is all of these people. And we've got a ratio as 5 to 2, pop to rap. What we can write straight away is pop is 28 plus x, and the rap is x plus 1. Now, if we've got a ratio of 5 to 2, what I can do is kind of swap those around and say, well, 2 lots of these people will be the same as 5 lots of those people. So I've formed myself a little equation there that I'm going to solve for x. 2 times 28 is 56. 2 times x is 2x. And that's the same as 5 times x is 5x. 5 times 1 is 5. Solve this by taking away 2x from both sides. You're left with 56 equals 3x plus 5. Take 5 from both sides. 51 equals 3x, and divide 51 by 3, you get x equals 17. 3 17s are 51. It does say work out the total of number of students in the survey, so I know now that this middle zone, x, is 17. All I need to do is do 28, add 17, add 1, add 13. So what we get, 17 add 13 is 30, add 1 is 31, add the 28, 59. Part B says a student is selected at random. What's the probability that they do not like rap given that they like pop? So as soon as we're given the fact that we like pop, I'm only picking out of these students. So 28 add 17 is 45. My probability is going to be out of the 45 students that like pop. And what I want is the ones that do not like rap. That's these 28 students out of the 45. Question 15, we've got a equilateral triangle, 2, 2 and 2, and we're showing that tan 30 is 1 over root 3. So we're just going to do some work on this triangle. If it's equilateral, then every angle is 60 degrees. And if we've cut this triangle in half, then that angle there is 30 degrees. So I'm going to delete the 60 because I'm not interested in that. This is talking about the tangent of 30. What I need to work on tangent, if I just write Ka Toa, the tangent trig identity involves opposite and adjacent. So I need my opposite. This is the hypotenuse. I also need my adjacent. So what I'm looking for is these two sides. Well, straight away I know my opposite. My opposite is 1. If this whole length is 2, then that measurement there is 1. What I don't know is my adjacent. So I'm going to just draw this triangle out. down here, and I'm going to say, well, I know that this is 1 and this is 2. What I don't know is the adjacent, this up and down measurement. This is Pythagoras' theorem. So if I call that A, that B, and that C, and then say A squared plus B squared equals C squared, you get 1 squared plus question mark squared equals 2 squared. This comes out at 1 plus question mark squared equals 4. 2 squared is 4. Question mark squared will be 4, take away 1, which is 3. And therefore question mark is the square root of 3. Question mark is actually my adjacent, so my adjacent is root 3. And if I just go back to this here, the tangent of 30, the angle that I'm interested in, equals my opposite over my adjacent, which is 1 over root 3. Exactly what they told me it was. Question 16, we've got some recurring decimals and we're told to multiply them together. We want an answer as a fraction in its simplest form, so I'm going to change these into fractions first. We've got x is 0.666. Following this process to convert recurring decimals to fractions, work out what 10x is. That's 6.666. And straight away I've got these matching numbers after the decimal point. So I'm going to do 10x, take away 1x, and what that gives me is 6.666, take away 0.666. Sixes take sixes, all vanish, and you're left with just an answer of 6 there. I can do 10x take 1x, which is 9x. And what we get is 9x is 6. So my initial x, my recurring decimal, is 6 over 9. And 6 over 9 is 2/3. You may have already known that without doing this process. I'm going to look at 0.54, where the 5 and the 4 recur. So we get 0.5454, and that would keep going. Same process, 10x. Move the digits to the left. We get 5.4545. We have to keep going here. What's 100x? Again, digits to the left. 54.5454. I want this and this because I've got that matching pattern after the decimal points again. So I'm going to pick up 100x and 1x and do a subtraction. And what you get is 54.5454, not right anymore. Take away 0.5454. And we know that 4 take 4 is gone, 5 take 5 is gone. You're left with 54 take 0, which is 54. 100x take x is 99x. So I know that 1x, my initial decimal here, is 54 over 99. I can simplify that. I know that 99 divides by 3 to give me 33. I know that 54 divides by 3. 5 add 4 is 9, and that divides by 3, so 54 will divide by 3. And I think 54 divided by 3 is 18. This will simplify again. They'll both divide by 3 again. 18 divided by 3 is 6. 33 divided by 3 is 11. 11 is prime, so no more simplifying there. Don't forget to actually answer the question. This was a multiplication, so I'm doing 2/3 multiplied by 6/11. 2 6s are 12. 3 11s are 33. Will both divide by 3 there. 12 divided by 3 is 4. And 33 divided by 3 is 11. There's your final answer. Question 17, we've got tons of information. We've got these strips of wood that have been put together to make these wooden frames. And then there's a load of algebra. And we're aiming for an area of 96 centimetres squared. So what I need is this multiplied by this to come to 96. And that's where I'm going to start. Now, if this whole measurement here is 2x, and I know the width of these pieces is 2, then that measurement there is 2x, take away 4. I'm taking away 2 there and taking away 2 there. I also know that this measurement here is the whole x. Take away 2, take away another 2. That is x take 4. Now what I can do is create a little equation that says this multiplied by this must come to 96. So I'm going to do that now. X take 4 multiplied by 2x take 4 has to come to 96, the area enclosed by the frame. This is now a quadratic, double brackets to expand, so let's do it. X times x, x times 2x is 2x squared. X times minus 4 is minus 4x. Minus 4 times 2x is minus 8x. And minus 4 times minus 4 is positive 16. That still comes to 96. Tidy this up a little bit. 2x squared. Take 12x plus 16 equals 96. This is a quadratic, and ideally we want it to equal 0. So I'm going to take 96 from both sides. And you get 2x squared minus 12x. Take 96 from both sides will give me negative 80 equals 0. There's a note little shortcut here. Everything in this quadratic is a multiple of 2. So I'm just going to divide throughout by 2. And you get x squared minus 6x minus 40 equals 0. And now I'm hoping I can factorise that quadratic and get it into double brackets. I'm looking for two numbers that add to minus 6 but times to minus 40. They are minus 10 and positive 4. So I'm going to put those into my double brackets. You get x take 10 and x plus 4. If I'm solving this quadratic, then x has got to be 10 or minus 4. Now they are the solutions to the quadratic. However, x can't be minus 4 because this is a length. So we can't have a negative length. So although that's correct in terms of maths, it's no good for this question. My x has to be 10. What I can do now is transfer that back onto my original diagram. If x is 10, then these are 20 centimeters wide, these frames. I also need this measurement. So x is 10, that measurement there is 6. Why have I done that? Well, I need to see how many of these frames can be created from a 1.6 meter piece of wood. So this here is 160 centimeters. Each frame uses 20, then another 20, that's 40, plus 6 plus 6. Each frame uses 52 centimeters of wood. So let's just see how many we can get from 160 centimeters. 52, add another 52 is 104, add another 52 is 156. I know straight away that if I added another 52, I'd go over my length of wood. So 156 centimeters is 3 frames. Question 18, we've got some arc length work to do. All this information is just describing the diagram. There's only one thing that's really important, and it's this ratio here. What it's saying is if you compare this radius to this radius, they're in the ratio 2 to 3. So I'm just going to write something down here. The radius OC, the bigger one, is 1.5 lots of OA. If you look at these two numbers here, 3 is 1.5 times bigger than 2. So I've just written that down there to show that this radius is 1.5 lots of the smaller one. I can actually write that as 1.5 R. And then I've got my two radiuses for my arc length, if you like. I know the first one is R and the second one is 1.5 R. We're actually asked to work out arc length. So I'm going to work on this smaller one first, AB. What we've got is 60 degrees out of 360 multiplied by pi multiplied by diameter. Pi times diameter is the full circumference of the circle, and I've got 60 degrees out of 360. That is the same as 63 sixtieths multiplied by pi multiplied by, be careful, diameter is 2r, not just the radius. We can simplify this. 60 out of 360 is actually a sixth. Multiplying by 2 gives me 2 sixths. And we've still got pi and we've still got r. And that actually simplifies further to 1/3 pi r. So that is the arc length of AB. We'll do the same thing for CD. We've still got 60 3/60ths. We're still multiplying by pi and multiplying diameter for arc length. That gives us 60 3/60ths times pi times, be careful, my diameter is not 1.5 r. I need 2 lots of the radius. So multiplied by 3r. The radius is 1.5 r. The diameter is 3r. Let's simplify this. Remember, 60 3/60ths is just 1/6. Multiplied by 3 gives me 3/6. and we've still got multiplied by pi and still got multiplied by r. The question actually wants you to add AB to AD. So we've got to do a third pi r, add 3/6 pi r. So what we really need to do is a third, add 3/6. Well, that's the same as 2/6 added to 3/6, and that there is 5/6. What you've got is a third pi r added to 3/6 pi r, which is 5/6 pi r. There's your final answer. Question 19, we've got an equation of a circle given as x squared plus y squared equals 169, and we're showing that this point lies on the circle. Well, straight away you've got an x and a y, and you just want to show that those values follow this rule. So I'll rewrite the equation: x squared plus y squared equals 169. X is minus 12, so we're going to do minus 12 squared added to 5 squared, and I'm hoping that that comes to 169. Minus 12 times minus 12 is 144. 5 times 5 is 25. And 144 and 25 is 169. That is correct. So that point lies on the circle. Part B says find the equation of the tangent at the circle at this point, minus 12, 5. So I'm looking for the equation of that line there. The tangent to the circle at minus 12, 5. What I can do straight away is work out the gradient of that line there. Okay, so that line there, I'll just sketch it out separately, is a straight line there that is 12 across and 5 up, just by thinking about the coordinate. And I can work out the gradient m just by doing the up measurement divided by the across measurement, and up is 5, across is 12. So the gradient of this line here is 5 over 12. I can turn that into the gradient of my tangent. These two lines are perpendicular. So if I'm now thinking about my green line, the gradient of that comes from flipping this gradient over and going from positive to negative or negative to positive. So the gradient of my tangent is minus 12/5. What we've got now is three things. We've got an x coordinate, which is minus 12. We've got a y coordinate, which is 5. And we've got a gradient, which is minus 12/5. We can substitute all of those into y equals mx plus c. And what we'll work out is the missing c. Y is 5, so 5 equals m is minus 12/5. X is minus 12, so I'm timesing by minus 12. And remember, we don't know what c is. Start to work this through. We've got 5 equals minus 12/5 times minus 12 will be actually 144/5. Just do the minus 12 times the minus 12. And that is still plus c. In order to work out c, I need to do 5, take away 144/5. That is your missing intercept c. At this point, I realise I've actually made a mistake, so I'm just going to change this and see if you can follow what I've done. This original gradient is actually sloping downwards, so that would be negative 5/12, which means that my gradient is positive 12/5. So I can change that all the way through now. That is a positive. That is a positive. And when you do positive 12 times negative 12, you end up with negative 144/5. That means this is an addition there. So what we've got to do now is 5 added to 144/5. Well, 5 is 25/5. And I'm going to add 144/5. That is C. 25/5 add 144/5 is 169/5. I'm just going to take my y-intercept and my gradient and write the equation of this tangent. It's going to be y equals 12/5 mx plus c plus 169/5. There's your equation of the tangent.